Hello all. So today we are going to discuss about the Kjeldhals method in an easy way. See, don't skip this video. Like I will explain how NCRT is explaining based on that also, and how easily without mugging up any formula, without by adding any kind of formula, you can easily solve Kjeldhals method. You just have to understand what is the concept behind it. Okay. So first, what we are doing? What is your intention? We have to find percentage of nitrogen, right? And how to find the percentage of nitrogen? Percentage of nitrogen will be equal to mass of nitrogen contributed in that compound divided by total mass of that compound into 100. This is the simple thing, right? Everyone will be knowing that. So what is our intention? We have to find out the mass of nitrogen here, right? So mass of nitrogen is what? So mass of nitrogen, we know number of moles of nitrogen will be equal to given mass or mass of nitrogen in organic compound divided by molar mass of nitrogen, which will be equal to 40, right? Molar mass of nitrogen, which will be equal to 40. Therefore mass of nitrogen will be how much? Mass of nitrogen will be equal to number of moles of nitrogen into 14. So what is our aim? Our aim should be to find out the number of moles of nitrogen in the compound. Now I am going to say what experiment we are going to do to find out this. See, we are taking an organic compounds which containing nitrogen. First, we will add H2SO4. This is an NCRT line. Organic compound, we will add H2SO4 to convert into ammonium sulfate, NH4 twice SO4. This process is actually called as digestion. It is not mentioned in NCRT. Just for your knowledge, I am saying. Okay, NH4 twice SO4. Now this NH4 twice SO4, I need to find out the number of moles of nitrogen, right? So what I am doing, this will be diluted, it's not given there. Now what I am doing, this NH4 twice SO4 is passed through NaOH, okay? It will be made alkaline with NaOH, that NH3 is formed. The all nitrogen which is there in the compound has been converted to ammonia. Now this ammonia we will collect it. Okay, so once this NH4 NaOH is alkaline, when we make it NaOH alkaline, the NH3 gas will be evolved. Now this NH3 gas will be evolved and collected where? You can see here again NCRT 2 NaOH, Na2SO4, 2 NH3 and H2O. See NH3 where it is collected. This has been collected in a particular flask containing H2SO4. NCRT is mentioning H2SO4. In this diagram it is mentioned boric acid, leave it. H2SO4 is mentioned in NCRT. Now the NCRT is using that excess H2SO4. Okay, excess H2SO4. Excess H2SO4 and its volume is VmL. Okay, excess H2SO4 which is having volume VmL. Now what? NH3 will be collected here. So NH3 will be absorbed, like how much NH3 will be there, that much H2SO4 will, means whatever record H2SO4 will absorb that. Now there will be a left one, right? Left one will be the left H2SO4, means the H2SO4 which is not gonna react with NH3. Some amount of excess H2SO4 we are taking, in that some amount of some amount of H2SO4 will absorb the whatever NH3 has been collected. So now rest of the H2SO4 will be left over. Okay, rest of the H2SO4 will be left over. Now what we are going to do, we will titrate this with NaOH. We will titrate this with NaOH. In the conical flask, we have NH3 absorbed with H2SO4 and we have rest H2SO4 which is not reacted with NH3 or which is not absorbed in NH3. Now this left H2SO4 will act as an acid, leftover acid, and will react with NaOH, right? So that I am taking as, okay, see here, this particular H2SO4 we are taking and that we are going to titrate with NaOH. Now if I find out how much NaOH is used for this titration, how much NaOH, using titration we can find out, right? How much NaOH is used for this titration, then I can find out how much H2SO4 is used in titration. Now if I know this one, initially I have some quantity, suppose some x quantity, in that this much titration, whatever used in titration I found out, then I can find out this one, means initial minus this reacted exact. Initially x was there, some reacted was there, if I minus that I will get this amount. Okay, so this is how NCERT is finding out the NH3 reacted with H2SO4. If I am finding NH3 reacted with H2SO4, how much H2SO4 used in reacting with NH3, then I can relate it with number of moles of nitrogen. How it's going to come? Let's see with easy trick. First I will discuss with easy trick. Okay, first I will discuss it with easy trick, then you will understand. Okay, now let's see what they are using, what are the terms they are taking. That terms alone I am using from NCERT just to derive into that particular equations which is coming into NCERT. You just have to know the concept, because it's not mandatory you have to take the exact terms, V1 is which one, V2 is which one from NCERT, but you should know the concept, then only you can apply it. For example, what are the NCERT term which is used? See here, you can see here VML. VML is what? Let the mass of organic compound is M. I am just writing that mass of organic compound is equal to M gram. Okay, now what did I said? It's going to titrate, right? Volume of H2SO4 molarity M taken VML. Okay, so excess H2SO4, right? Excess H2SO4 which is titrated with NH3 is taken VML and molarity is M. Okay, molarity is M. Now you see volume of NaOH of molarity M. Again, volume of NaOH of molarity M used for titration of excess H2SO4 is V1 ml. So volume of NaOH titrated with excess. Initially I have given this titration, no, NaOH is titrating with H2SO4. That is how much? V1 ml, and its molarity is also M. Okay. Now, okay, this much only we required. Now how the NCERT is explaining, I will come to that. Now how the we will come into that equation. Now see here, we are only using law of equivalence. Okay, we are only using law of equivalence here. So according to law of equivalence, we know that N equivalent of A is equal to, or A reacted is equal to N equivalent of B. If a two reaction is happening, A plus B gives C, N equivalent of A is equal to N equivalent of B is equal to N equivalent of C. Right? Redox reactions you must have studied that easy. You just want to know about the basic of N equivalent, then it is easy. N equivalent different equation is there. N equivalent is equal to normality into volume, that is one equation. N equivalent is equal to N into N factor. These two things we know, right? Using that we are going to do this. Now first who is reacting? H2SO4 is going to react with NaOH, right? H2SO4 is, one second, I will change the pen. H2SO4 is going to react with NaOH. So we can say that N equivalent of H2SO4, whose H2SO4, whose it is? Excess, right? H2SO4 excess is equal to N equivalent of, means reacted, okay, even if it is excess, whatever reacted, that only will be taken. Okay, at N equivalent of H2SO4 is equal to N equivalent of NaOH. We know molarity of NaOH is how much, and we know normality is equal to molarity into N factor, right? So N into, this is N factor into molarity into volume, right? This is N equivalent of NaOH. N equivalent is equal to normality into volume. Normality is molarity into N factor. So molarity into N factor into volume. Now what was the volume of NaOH used? V1. Molarity is V. And what is N factor of NaOH? 1, because only one OH minus is there. Right? Now N equivalent of H2SO4. What is the volume of H2SO4 used? We have to find out. Excess is V1. Sorry, excess is V. Altogether we took V. But reacted is not V. So we have to find out. So take it as an X. Okay, take it as an x. Okay, I'm going to find out reacted H2SO4. Let a reacted H2SO4 is xml. Okay, now I'm going to find. So here see, n into H2SO4, therefore it is again n factor into molarity into x, right? So what is x? X will be, what is n factor? N factor is 2. Molarity and molarity cancel because both are same molarity we have taken. So what is x? Volume of x used, or volume of H2SO4 reacted is equal to V1 by 2, right? V1 by 2. So that's what NCERT is mentioned. I will come to that. Okay, volume of H2SO4 reacted is V1 by 2. Now I got it, right? V1 by 2, I got it. Now suppose I'm going to react with now we have to find out the NH, because now this H2SO4, how much NH3 absorbed, the NH3 absorbed H2SO4 we have to find. Initially we have taken total V, total this was VML, and in that some amount is reacted with absorbed NH3. The rest one is reacted with what? NaOH. The rest one is V1 by 2. The complete amount is V. Therefore, what is absorbed in NH3? That is V minus V1 by 2. This is the H2SO4 volume that NH3 absorbed. Right? This is the H2SO4 volume that NH3 absorbed. Now see here, we got the volume of NH3 absorbed, H2SO4. Now I can same write this, no, N equivalent, because NH3 is going to react with H2SO4. N equivalent of NH3 is equal to N equivalent of H2SO4 absorbed, right? So N equivalent of NH3, what I am writing? N into N factor, because we don't have volume of NH3, molarity, nothing is there. So I am just writing N into N factor. We have to find number of moles of NH3. That's it, right? And like see, N equivalent of H2SO4, its molarity. Molarity is M into N factor is 2, right? Molarity into N factor into volume. Volume is what? V, this one, right? V minus V1 by 2, right? Now you can find out N factor of NH3 is what? N factor of NH3 is 1, no? Right? NH3 will absorb only 1 H plus to get NH4 plus, right? Only 1, right? So it is 1. Therefore, N is equal to M into 2, or 2 into M into V minus V1 by 2. This is number of moles of NH3. Now you say number of moles of N of NH3 will be equal to N of nitrogen, right? Because 1 mole of NH3 has 1 mole of nitrogen. So we got N of nitrogen, which we wanted here. What we wanted here? Where is it? Yeah, we wanted N of nitrogen and we got that. What is it? N of NH3 is N like this much, right? This is like, therefore mass of given mass or mass of nitrogen is how much? Mass of nitrogen is equal to how much? Mass of nitrogen is, yeah, N into molar mass. Molar mass of nitrogen is 14. So N is what? 2 into M. Oh, one more thing which I forgot here. When I'm saying taking N into N factor, very bad. See, I forgot that. Here N into N factor, molarity I'm taking. Then molarity into volume. Volume should be in liters, right? Volume should be in liters, which I forgot, right? Volume is here in ml we are collecting. So we have to convert that into liters. How to convert that into liters? Divide ml by 1000. So here a 1000 is also will come. So basically here a 1000 will also come, which I forgot. Okay. So mass of N is equal to N into 14 into 2 into, okay. Now see, mass of nitrogen is N into 14, which is equal to number of moles into molar mass, right? So which is equal to, what is N? 2 into M into V minus V1 by 2 into 14 divided by 1000, right? This one. This is the n, this is into 40 divided by 1000. Therefore, what is percentage of nitrogen? Percentage of nitrogen is mass of nitrogen divided by molar total mass, that is m, into 100, right? So I am doing that, which is equal to mass of nitrogen is 2 into m into v minus v1 by 2 into 14 divided by 1000 into m is also there, right, into 100. You see, that is the equation. Yes or no? Yes or no? This is the equation NCERT is giving. 14 into molarity into 2 into v minus v1 by 2 into 100 by m, right, 1000. See, if you know this concept, you don't want to mug it up. Just this, n equivalent of this is equal to n equivalent of that. Whichever two species are reacting, its n equivalents are same. You should know that equation n into n factor is there. If volume is given, then we will use normality into volume. So if normality is given, you can do this concept. If molarity is given, you can do this concept. See, this is a matter, not mugging up, right? You are not by-hearting anything, you are just doing it. I hope everyone understood this. This is very easy to do if you didn't mug it up. If you mug it up, if they are just twisting the equations, instead of molarity, something else is given, instead of v minus v1 by 2, some other volume is given, then there will be a problem if you didn't understand the concept. Okay, so try to do in this way, it will be easy.